Hello, everyone. In this section 1.8, we are going to take a look at solving nonlinear inequalities. I'll go over one or two examples of linear inequalities, but then after that, then we will focus on quadratic inequalities and rational inequalities, and then absolute value inequalities. Okay, so 1.8. Inequalities. All right, so let's take a look at linear inequalities. So these are basically solved the same way as linear equations. The only difference is when you're multiplying or dividing by a negative number on both sides, then the direction of the inequality changes. Okay, so let's take a look. All right, so let's go ahead and solve this one. 5 minus 3x is less than or equal to negative 16. Okay, so I'm going to go ahead and write that down here. 5 minus 3x less than or equal to negative 16. So just like with equations, we try to get the variable x by itself on one side. Okay, so I need to subtract 5 on both sides. And that will leave me with negative 3x less than or equal to negative 21. And here, to get the x by itself, I would need to divide by negative 3. So this is the step that I was talking about, where it's a little bit different and you do have to pay attention. So here, when we divide by negative 3 on both sides, we do need to change that direction of the inequality. Okay, so let's take a look. When I divide by this negative number, and then what happens is this inequality will switch directions. And that's only if you are dividing or multiplying both sides by a negative number. Okay. Okay, so here on the left-hand side, we end up with x is greater than or equal to positive 7. Okay. Depending on the way WebAssign asks you to write the answer, this might be okay. Another way to write this is using set notation. So greater than or equal to 7. So that is saying bracket 7 all the way to positive infinity. Okay. So this is also another way to write it. Okay. If it had said strictly greater than 7, then I wouldn't use this bracket here. If it said greater than 7, then I would use a parenthesis. Okay. Let me just write it over here on the side. So if it said this, oops, strictly greater than. Okay. So if it said strictly greater than, I'm trying to get my pen to work, then it would be written with the parentheses instead of the bracket. And then you would have your 7 and your infinity. Okay. So if you have the greater than equal, then right here, greater than equal, you will use the bracket. But if you have strictly greater than, you will use the parenthesis. Okay. All right. Let's take a look at this example here. Let's solve this inequality. 1 less than 3x plus 4 less than equal to 16. Okay, so I'm going to go ahead and write that down here so we can do the work. Okay, so here we have the variable in the middle. And we do need to get that variable by itself. So I need to cancel out that plus 4. So I am going to subtract 4 on all three sides. So if I subtract 4 here, I need to subtract 4 here and here as well. Okay, so in 3 places. They cancel out there. And so I'm left with 3 less than 3x less than equal to 12. Okay, and then at this point, I am going to divide all 3 sections by 3 to get that x by itself. So solving for x, so I need to divide by 3 here. Okay, but then I have to divide by 3 in the other 2 places as well. Okay. And so here we end up getting 1 is less than x. So 1 less than x less than equal to 4. Okay, so that's one way to write it. If you're going to use set notation. So this is saying x is between 1 and 4, but does not include 1. So 1 will get parentheses, and the 4 will get a bracket, like this. Okay, there we go. All right, so that's linear inequalities. Let's take a look at nonlinear inequalities like quadratics and rational inequalities. Okay, so that's going to be the main focus of this lecture here, these nonlinear inequalities. Okay, these are much trickier to work out. There's more work involved. So nonlinear inequalities. All right, so when you're dealing with these quadratic or rational inequalities, the first thing you want to do is set the inequality to 0. And the reason why you want to do that is because you want to find these what's going to be called critical numbers, and these critical numbers for the most part are where the inequality equals 0. So we set the inequality to 0, and we solve that that equality to 0 to find these critical numbers. Okay, so the first thing you do, set your inequality to 0, and the second thing you do is determine critical numbers. Okay, and once you have your critical numbers and you have them on your number line, then you are going to test each interval on your number line. So I'm going to do two examples, one with a quadratic and one with a rational. Okay. All right, so here, first example. Suppose that I have x squared minus 3x less than equal to 18. Okay, so the first thing we want to do is set this to 0. So subtract 18 on both sides. And set it to 0. Okay. And so then I'm going to go off to the side here. To find my critical numbers. So my critical numbers are where this quadratic equals 0. So I'm going to go ahead and solve this quadratic. And we looked at ways to solve quadratics. You can use quadratic formula if you want to. I'm going to use factoring method. So x times x is x squared. And then I need a positive and a negative. And I'm going to use 3 and 6. I'll use the 6 here and the 3 here to give me negative 3x for the middle term. So it turns out x equals negative 3 and x equals positive 6. All right, so these are my critical numbers, negative 3 and positive 6. And this is how you find them whenever you have a quadratic inequality. Okay, so these critical numbers, we're going to take these critical numbers, negative 3 and 6, and we're going to plot them on a number line. Okay, so negative 3, somewhere down here, and positive 6, somewhere over here. Okay, so what happens is these two critical numbers, negative 3 and 6, divide the number line into 3 regions. Okay, so this is like region 1, this is region 2, and this is region 3. So what we have to do is figure out which region contains the solutions. Okay, so negative 3, when we plug in negative 3, we get 0, right? Because negative 3 and 6 are the solutions. So when I plug in negative 3, I get 0 is less than or equal to 0, which is true. So I will color this in. Okay. And then same thing with 6. When I plug in 6, I will get 0, and 0 is less than or equal to 0. So I will color this in. Okay. All right. So now to check each region, I just need to choose a number in that region, plug it in, and see if I get a true statement or a false statement. So over here in region 1, I'm going to go ahead and choose x equals negative 4. So that'll be the number I'm going to test. I'm going to test it by taking this negative 4, plugging it into this inequality right here, and checking for a true or false outcome. All right, so I get negative 4 squared minus 3 times negative 4 minus 18. And I want to know, is that less than or equal to 0? Okay. All right, so here I get 16 plus 12 minus 18. I want to know if that's going to be less than or equal to 0. I get 28 minus 18 is less than or equal to 0. And so I get 10 is less than or equal to 0. So 10 is less than or equal to 0 is false. So since the outcome turned out to be false for a number that I chose in region 1, then none of those numbers in region 1 are part of the solution. Okay, so don't shade that part of the number line. Let's go over to region 2. So region 2, I'm going to go ahead and choose x equals 0. Okay, because 0 is a number between -3 and +6. Okay, so let's plug that in. When I do, I get 0 squared minus 3 times 0 minus 18. And I want to know, is this less than or equal to 0? Okay, so I get 0 minus 18. And so that gives me -18 is less than or equal to 0. And that is actually true. -18 is less than or equal to 0. Okay, so since it is true, I will go ahead and I will shade this middle part of the number line, region 2. Okay, and let's go ahead and check region 3. A number bigger than 6. So let's try x equals 7. Okay, so plugging in 7, kind of running out of room here. So 7 squared minus 3 times 7 minus 18. I want to know if that's less than or equal to 0. So let's work that out. I get 49 minus 21 minus 18. Is that less than or equal to 0? And I get 28 minus 18. 28 minus 18 is 10. Is 10 less than or equal to 0? Absolutely not. So that turns out to be false. And when it's false, we do not shade that part of the inequality. Okay, so it turns out that the only part of the solution is between -3 and 6. So the way we write that, -3 is included in our solution set. So we are going to use a bracket on -3. And we're going to go all the way up to 6. And 6 is also part of the solution set. So we also put a bracket after 6. Okay. So that's how we would write the solution. Okay, so very important that over here you go off to the side and find your critical numbers by factoring and solving for that equation. Once you find those critical numbers, you plot them. And remember, the solution is where it does equal 0. So you already know whether or not to include -3 or 6, whether to shade in, and whether it's going to be a closed circle at -3 or an open circle at -3. Okay? Because right here, we said we want all the numbers where it's less than or equal to 0. And at -3 and 6 is where it equals 0. So that's why we shaded it in. Okay. All right. So those are quadratic inequalities. You do have to do the factoring, and you do have to check each region. Okay. So let's take a look at rational inequalities. Okay. Suppose that I have this one here. Okay, 2x plus 1 over x minus 5 is less than or equal to 3. Okay, so same thing, we do need to set this to 0. Okay, so I am going to subtract 3 on both sides, in which case I will end up with this. Okay, So again, we want to set these to 0. All right, so now we have a rational expression here on the left that we need to subtract. So we need to get the LCD. Okay. So here, let's go off to the side and do it. So I need to do 2x plus 1 over x minus 5 minus 3 over 1. Okay. And so the LCD here is going to be x minus 5, right? So I want my denominators to look like that. The first fraction already has x minus 5 in the denominator. The second fraction does not. So I will need to multiply, trying to get red. Okay, so I'm going to need to multiply over here by x minus 5, top and bottom. Okay, so when I do that, let me get my black pen back. Getting there. Okay. Then I end up with 2x plus 1 over x minus 5 minus, and up here I distribute the 3 and I get 3x minus 15 over x minus 5. Okay. And now that they have common denominators, then I can go ahead and subtract these. So 2x minus 3x is negative x. 1 minus negative 15 becomes positive 16. And the denominator remains x minus 5. Okay, so the way you find your critical numbers here when you have a rational expression is you find out where the numerator equals 0. So critical numbers. So we find out where negative x plus 16 equals 0. Waiting for my screen to move. Okay, so negative x plus 16 equals 0. And we also want to know where the denominator equals 0. So we want to find out when x minus 5 equals 0. Okay, so solving both of these equations, I end up with x equals 16. That's going to be one of my critical numbers. And I get x equals 5. That will be my other critical number. Okay, so these are the 2 points on your number line that will divide the regions. Okay. All right, so let's go ahead. All right, so we're going to put 5 on the number line and 16. So let's go ahead and put 5 somewhere over here, and we'll put 16 somewhere over here. And we see that the number line gets split up into 3 regions again. Okay, so let's figure out if we're going to have open circles or closed circles at 5 and 16. All right, so let's take a look at 5. When I plug in 5, I end up getting 0 in the denominator, which is undefined. So 5 cannot be part of the solution. Okay. When I plug in 16, I know I'm going to get 0. Okay. And 0 is less than or equal to 0. So I will shade this one. Okay. So 5, we leave it open. 16, we close it, because 5 will give us 0 in the denominator, which is undefined. 16 will give us 0, and 0 is less than or equal to 0. Okay, so again, this is region 1, this is region 2, and this is region 3. And we need to test each region by taking a number and plugging it in. Instead of this one up here, I am going to write the simplified version of that left-hand side, which is what we did here when we were finding our critical numbers. Okay, so that's what I'm going to be using. Negative x plus 16 all over x minus 5 less than or equal to 0. Okay, when I check. All right, so region 1, let's go ahead and use x equals 0. Okay, so when I do that, I get 16 over negative 5 is less than or equal to 0. And that would be true. So that would be true. So I'm going to go ahead and shade that part of the number line, right? Because this turned out to be true. If it's false, do not shade. Okay, so region 2, let's just check x equals 6. It doesn't matter what number you choose in that region. The outcome will be the same for all of them. Okay, so I always try to pick the smallest numbers. Okay, x equals 6. So 16 minus 6 is 10. And 6 minus 5 is 1. Is this less than or equal to 0? That would be no. So this is false. Okay, so that middle region turned out to be false. So we will leave it alone. We will not shade it. Okay. All right, let's pick a number in that third region. Smallest number we can choose is 17. Okay, so negative 17 plus 16. So remember, I'm plugging into this inequality right over here when I'm checking each region. So right now I chose x equals 17, so I'm going to plug it into this inequality. So negative 17 plus 16 is negative 1. 17 minus 5 is 12. Is this less than or equal to 0? Well, yeah, because it's negative. Okay, so yes, negative 1 over 12 is less than or equal to 0. That is true. So I will go ahead and shade that region. So here on the number line, region 3 will get shaded in. Okay, so we see we have this split region. Okay, so let me show you how to write that in set notation. So this region 1 goes from all the way forever to the left, which is negative infinity. So it's negative infinity all the way up to 5, but 5 is not included, so 5 will get a parenthesis, not a bracket. Okay. And then we use the union symbol. And then the next shaded area starts at 16, and it includes the 16, so we will use a bracket on 16, and it goes all the way to the end, which is positive infinity. I use a plus in front of the infinity. Do you have to? No. Okay. But this is how you would write the solution set right here. Okay. Negative infinity all the way up to the 5, but not including the 5. And then bracket on the 16 all the way to positive infinity. Okay. So these are the two nonlinear inequalities that get solved differently using critical numbers and these test points. Okay. All right. So that's that part. So now we will go into solving absolute value inequalities. Okay. So these are a little less complex. Absolute. I was going to say absolutely, but that's not correct. Trying to get my pen back. Okay. Absolute value, inequality. Okay, so we have basically two types of inequalities. Okay, so number one, we have it where the absolute value, regardless of where the sign, the inequality is pointing at, we have the absolute value of some expression, and we have the inequality symbol pointing at it. So the absolute value of this expression is less than or equal. It could be strictly less than or less than equal to some number. Okay, so that's one kind of inequality. The other kind is where the inequality or the absolute value expression is greater than some number n. Okay, so they get set up differently. So this is what you need to know here. So if we want the absolute value to be less than or equal to n, then we're sort of bounded on both sides, on two ends. Okay, then that means that your numbers are the numbers that are somewhere between negative n and positive n. Okay, so this is how you would set up your inequality, and you don't have any absolute value symbols here, and then you would proceed to solve for x. This one over here, you're going to have two separate inequalities. Since you want your absolute values to be bigger than or equal to n, you're going to have one that's greater than or equal to n, or less than or equal to negative n. So if you can imagine, these are going to be the numbers that are farther away from zero. So, so like if you're thinking about numbers that have absolute values more than 10, then we're thinking about all the numbers that are more than 10 units away from zero. So like 11, 12, 13, 14. And then same thing on the negative side, the ones that are farther away from zero. So like negative 11, negative 12, and all the decimals in between. All right, so let's take a look. And we'll just do two examples and then finish up. All right, suppose that I have this 12 less than absolute value 8x plus 3. Okay, so I'm trying to mix this up a little bit for you so you can get used to identifying what kind this is. So here, the absolute value, you need to look at it in relation to the inequality. So the absolute value is greater than. So when we look at the two cases up above, this one would follow case 2. Okay, so the absolute value is greater than. So if that's the case, then we have two inequalities that we need to set up: 8x plus 3 greater than 12, or 8x plus 3 less than negative 12, because these are the ones that are farther away than 12, right? Okay, so let's go ahead and solve this. We solve each one. So subtract 3 both sides. So 8x is greater than 9. Divide both sides by 8. So x is greater than 9 over 8. Okay. And then same thing here on the right-hand side. 8x is less than negative 15. And then divide both sides by 8. So x is less than negative 15 over 8. Okay. And let's take, so that's case 2. Let's go ahead and take a look at another example. Let's take a look at this one. 5x minus 2, absolute value less than 6. Okay, so we have this one here, and again, look at the absolute value in relation to the inequality, and so it's the absolute value is less than. So when we look at the two cases up above here, that would be the first case. Absolute value is less than n. Okay, so when we set it up, it's going to be this sort of in-between statement right here. Okay. All right, let's scroll back down to the problem. Okay. All right, so we said it's going to be the in-between problem, and we know it's going to be in between negative 6 and positive 6. Okay, and then all you do is solve this inequality. So add 2 to all 3 parts, right? So we're going to add 2 here, but we also have to add 2 over here and over here. Okay. All right, so waiting for the 2's to show up. All right, so here on the far left side, we get negative 4. And in the middle, we get 5x. And the far right side, we get 8. Okay. And now we have to still solve for x. So we need to divide all 3 parts by 5. Okay. So divide here by 5, but then you also divide here and here. Okay. And that would be your answer. Negative 4 over 5 less than x less than 8 over 5. Okay. Another way to write this, if you do use set notation, is by using, since these are strict inequalities, not less than equals, we're going to use a parenthesis, negative 4 over 5, comma, 8 over 5, parentheses. Okay. Again, we use parentheses if you have this one or this one. Use parentheses. Wait for it. Okay. When you have that inequality or the other one, you're using parentheses. But when you have the less than equal or the greater than equal, then you can use the brackets. Okay. Top one, use parentheses. The bottom ones here, you use brackets. Okay. All right. So that is it for 1.8. We are skipping 1.7. Okay. So we have one more section for chapter 1, and then we move on. All right. Have a good day.